Everyone, I want to present a paper we published in the journal Smart Cities from the MDPI. If you go here, volume 4, issue 3, our paper is the cover issue. And we describe a solution that we call iBikeSafe. It's a complete IoT solution to support the detection of different types of environmental information from bikes that are equipped with a sensor unit. We embed some processing and sensing capabilities on bikes. And we describe how this information can go from the bikes to a cloud-based service and from there to any question application. We define all steps, all process to this complete architecture. And we also assess the use of this architecture using an example in a Brazilian city. And whatever, it's a very interesting paper. I think so. Okay, I know I am one of the authors, but I believe it's an interesting paper that you should pay some attention, because this can be a good contribution to the development of more sustainable mobility solution for becoming smart cities that we need for this century in order to face all climate changes and problems we are expecting for this century. Okay, let's click on this paper. It's a paper. The complete title is iBikeSafe, a multi-parameter system for monitoring, evaluation, visualization of cycling paths in smart cities targeted cycling adverse conditions. Why? Because we are concerned with high pollution levels, noise pollution, UV radiation, very low or high humidity, risk of accidents, the general infrastructure of bike paths, concerning the risk of the cyclists to be involved in accidents. So we want to understand how cities are protecting or not, or how safe and healthy is to cycle in a city. How are the bike paths being created and supported by the cities? This is the basic idea of this paper. It was written by Franklin Oliveira, Daniel Costa, me, Luciana Lima and Ivanovic Silva, and a collaboration between two Brazilian universities, UFS and UFRN. And okay, this is the paper. It's open access. We can freely, openly access the paper. We have some very interesting information about description of the actor, how it's related with other works, and how it is can be constructed and implemented in real situation, described a lot. We have some interesting figures here. Let's see, we have the general architecture. We have bicycles will be equipped with sensor units that we retrieve information from the environment, okay, locally store that information to be processed and transmitted to the cloud when the bike is under the coverage area of a base station. We expect to use Wi-Fi as the basic wireless technology, but we can use different technologies because due to cost restrictions, we believe that in some point it may be hard to deploy bicycles that are online all the time. We can use, okay, LoRa, we can use 5G maybe, but the cost may be high. So we believe that for now, the better idea is to sense the environment and store the information locally. And when the bike reaches its base station, it can transmit the retrieve information to the cloud. It's cheaper to implement this way. The information will then be processed in different modules, different operational modules, will be formatted, and then will be available to any request application. It's a way to, okay, we want to retrieve information, process them, and make them available to any request application to make any use. For example, we believe that one very simple idea of this architecture is to support quality assessment of bike paths in smart cities. Okay, but we can also perceive how cities are dealing with diverse conditions. Okay, we know that we have a lot of climate change issues in this century. We have to deal with pollution, air pollution, emitted by cars. We have high levels of noise pollution. We also need to deal with these problems, and provide information by architecture can support different types of application. We define different modules, and okay, this is the general idea. We define how the protocols can be used. We use HTTP as basically request and response protocol, internet-based protocol, and how the information will be retrieved, will be stored in different database, and how different modules can be used. Okay, we define the bike sensor module to retrieve information, the bike path gen to model the bike paths, bike data as a superset systems to provide information from different systems that may help us to better understand the bike paths. The bikeway, it's one of our proposals describing a different paper that provides a metric, a quality metric to evaluate the quality of bike paths, exploit different types of data. Here is the city of Natal. We select a very long bike path around the main campus of the city. This bike path history is interesting because it's the road share with cars and bikes. So we have some risk of accidents for the cyclists. So we want to evaluate this, and also pollution level that we had there, and we could retrieve from different systems, and the high level of UV radiation in that city. Okay, we made a lot of data processing. This is the proposed prototype of the bike sensor unit that would be attached onto bikes to retrieve different types of information. In this case, we have temperature, humidity detection, ultraviolets, and we also detected the sunlight exposure, because we know that bikes may have a high level of risks of accidents during the night. Okay. This is how we assess the quality of the bike paths around the campus. Okay, different results. Okay, these are the samples we retrieved in our experiments, and we plotted different colors according to the quality, using that metric that we proposed before. Greener, the greener it is, the better it is, safer and healthier to the cyclist it is. The more red it is, it's not the ideal situation for the cyclist concerning the safety and health. Okay, so I invite you all to read this paper and to make comments and to collaborate. Okay, thank you very much, and see you next time.